Hi class, today we are going to continue some work with electronics and electricity. We're going to deal with power and dealing with a couple of different equations to find power. So let's go ahead and get started. We'll do one part at a time. So we start with a 3 ohm light bulb and a 6 ohm light bulb connected in series and hooked up to a battery. Wants to know which of the two will shine the brightest and by how much. So first of all, let's go ahead and draw them in series with a battery. So to do that, it's pretty simple. We just have our battery here. We don't know the voltage, but doesn't matter. And we go with, say, a 3 ohm light bulb. My light bulb's a circle. And a 6 ohm light bulb. And then back to the battery. So very simple in series. We also need to know that one of the equations for power we've talked about is current squared times resistance. All right, so we want to figure out which one's brightest, and although all net energy we use to light a light bulb goes through creating light, some of it goes to heat. We're going to ignore that and just assume that the power dissipated across it is directly proportional to the light bulb's brightness. So more power means more brightness. In series, two light bulbs have the same current, so same current running through the whole thing. That can't change because there's nothing in parallel there. However, when one has twice the resistance, obviously the second one has twice the resistance of the first one. So we want to use the idea that power is I squared times R, figure out which one has more power going across it. Okay. So if we take the power of the 6 ohm bulb, that's just I squared times the resistance of the 6, which is 6 ohms. And then we want to divide that by, say, the power of the 3 ohm, which again should be I squared because this current should be the same, over 3 ohms. And again, we said we know that the current is the same, so those cancel out, our units cancel out. So we get power of the 6 ohm over the 3 ohm is simply 6 divided by 3, which gives us 2. So all that means is that the 6 ohm light bulb is twice or 2 times as bright as the 3 ohm light bulb. So the 6 ohms brighter and twice as much so. Okay, so that's part 1. That's not too bad. To come back here and we look at part 2, we have the exact same resistors, same bulbs, resistors, but now they're parallel instead of in series. So now we want to know which of the two is going to shine brightest. Okay, so let's draw that again, see what we got different. So we still have our same battery, but now we have a 3 ohm light bulb resistor and a 6 ohm, but now they are in series. So in this case, we want to use the other version of our power equation, which is power is equal to voltage squared over resistance. Okay? And if we want to compare those two, well, we just do the same thing we did last time. So we're comparing the power over the 6 ohm divided by the power of the 3 ohm. Same as usually before. But that's going to give us something a little bit, V squared over 6 ohms, or V squared over 3 ohms. Voltage dropped against each one. Since they are in parallel, they have the same voltage going across each one of them. Whatever the battery is, the total voltage gets dropped off on the 3 ohm. In one loop, the total voltage gets dropped off on the 6 ohm in the other loop. So those voltages cancel out. So we're left with 1 over 6 ohms over 1 over 3 ohms. And we will see that, well, that gives us 1/2. So the combination is 1 over 2. So in this case, 3 ohm light bulb is brighter by twice as much.